My name is Rob Lee. I'm the head of faculty and the curriculum director here at the SANS Institute. And lots going on this week in the cybersecurity world. Executive order by the president came out yesterday with a lot of things actually related to the solar winds, but the timing of it is very applicable because of the recent cyber attacks that have gained nationwide and worldwide news as a result of the ransomware attack on the Colonial Pipeline. That has caused a lot of disruption in the service as a result of them shutting it down. We at the SANS Institute, believe that when these kind of events happen, we need to turn to our experts, our practitioner instructors who lead the different fields inside SANS, from digital forensics, offensive operations, and of course, industrial control systems that we end up having here that we're going to be focusing on today. The main idea is that, despite what you're reading in the news and despite everything else, that we want to be able to tell you what is actually going on, our perspective on it, and you do it in a very balanced and crucial way to inform, not cause panic, and also so people can, make their own judgments on what this means for their own potential organizations or how potentially affect you personally. This webcast is primarily focused in on the operational technology systems and the effect of cyber attacks on it. In this particular case, with the ransomware attacks that hit Colonial Pipeline earlier this week, and its drastic impacts that we're currently still feeling across the nation. We've invited Tim Conway and Jeff Shearer, who are two of our leading minds in the ICS side of the SANS world. Tim Conway is our director of everything ICS at SANS, all the courses and all the summits that we end up doing. Tim has his hand in working with Robert M. Lee and his entire team. Jeff is our core author of one of our most popular courses, ICS 612, our ICS cybersecurity class, which is going to be making a new debut later this year once we return to in-person training again, because it actually has a lot of components that you actually have to have in person. We cannot actually do that one remote, unlike a lot of our other classes that we can do live online. So I'm going to be turning it over to Tim and Jeff. Just a side note, they have already informed me that this presentation is going to take up the full hour. So what we're going to do, if you end up having a question, we're going to collect the question and make a blog that both Tim and Jeff will respond to that blog, and we'll post online to both Twitter and LinkedIn so everyone could see their questions answered in that format. That way you can ask a question, think it'll be answered, because we may be short on time to be able to address all the questions that folks may have. Without further ado, I want to hand it over to Jeff and Tim. Thanks, guys, for putting this presentation together.
Thank you, Rob Lee. Appreciate it. Rob T. Lee, the most important part of that, to distinguish between Rob M. Lee. And for those from Rob's team that are on, I don't know that Rob would say I'm deeply involved in things going on, but Rob and I do talk quite a bit. I appreciate kind of the comments in regards to we are going to run the full time here. Jeff and I, if you've ever seen either one of us present, we're like water. We kind of fill our space. So we will use everything we have. Just real quickly, appreciate the introductions for Jeff. I wanted to highlight a couple of things as when we get into parts of this presentation and we're talking about some of these specific design areas, things that he's seen across his career. I just want to sort of highlight, Jeff has been sort of in this space active system integrator for over 23 years. From a commercial engineering group at Rockwell, doing quite a bit in regards to kind of converged plant-wide designs across industrial automation control systems, industrial DMZs, a lot of architecture validation, site-to-site VPN converged sort of plant-wide architectures. This is an area where he spent a considerable amount of time and spending a lot of years in a number of different environments. So exposure to kind of manufacturing, chemical, oil and gas, lots of different sectors as well, involving industrial control systems, distributed control systems, and SCADA environments. So we're blessed to have him here with us. And definitely when we get into some of the architecture discussions on kind of why an attack that's impacting IT could potentially impact operations, and just really how people are defining the differences between IT and OT. So without further ado, we are going to move into what we're going to cover today. So with the limited time we have, as Rob had indicated, expect follow-ons from this webcast, either from the perspective of answering any questions that come in, but we are likely going to either create kind of a blog post talking about some of the things we've covered here and expand on them, or move down developing some more resources as ransomware and its impacts in operational technology environments is only going to continue to grow. And we're going to continue to see kind of changes and different guidance and a need for additional resources for asset owners and operators. So we are going to really try to focus on the ransomware in operational technology elements throughout this talk. There's been a ton of other great talks and great resources that really talk a lot about kind of the ransomware or impacts and how you can position your systems and defend in IT environments. We'll cover just a few minutes of that and then spend the rest of our time kind of moving into the OT spaces. So first, in a lot of ways, we kind of, throughout our careers, Jeff and myself, learning from events that occur in facilities that we've worked, or in responding to events at other facilities, and then learning from others through case study analysis, kind of in similar ways to safety programs and kind of near miss, or in some industries where they have kind of events analysis and full details of what occurred, how it was discovered, the full root cause analysis of the details, and then really consuming that, even though it may be in a completely different industry than yours. It may be IT and financial sector, but what could have been learned there may apply to you. It could have been a physical security event that impacted a large telecommunications company and how they had to respond to that with backup generators and switchgear. And as you think about what that might mean for your data centers, depending on what sector you're in, or specifically an electric sector event or a oil event, and how that applies to the place that you call home for your work environment. Through that case study approach in this webcast, we're going to be talking about, as Rob indicated, the Colonial Pipeline events. So some of the details, I am certain everyone on this call is familiar with the recent events this week impacting Colonial Pipeline and their operations. Just some details, kind of some of their system maps, working through 14 different states, largest refined products pipeline in the US, 100 million gallons of fuel daily across this 5,500 miles of pipe, about 280 different facilities. And that includes a number of different kind of terminal stations and refinery input stations, plus their own storage farms and various pumping and valve operation stations across their footprint. Ultimately moving a number of different products, kind of supplying about 45% of those products to the East Coast. Colonial Pipeline became aware to a number of people on Friday, May 7th, when they had to temporarily shut down all pipeline operations due to a ransomware attack on its IT business systems. We're going to talk a little bit about that kind of IT business system specifics in a few slides here. Just as an update since May 7th. So since May 7th on Friday when this occurred, there's been frequent updates being provided by Colonial Pipeline in regards to the restoration and their activities. As of today, so starting yesterday at 5 p.m., they began operational startup. So the ability to start restoration of delivery of product. And today, in about an hour, they are estimating full operation across all lines by noon Eastern. So the lines in green here are the markets that are currently being serviced. The lines in blue are those that they anticipate service to begin by midday today. So noon Eastern, in about when we end this webcast, everything should be green. So keep your eye on their website. They have been providing very frequent updates, and this was provided earlier this morning. Along with the updates they're providing on the operational side, they are also providing updates and information sharing on the kind of cybersecurity front. So a couple of items to highlight here. There's been some discussions recently in some testimony and some other items in regards to who did Colonial Pipeline reach out to and what did they share and when. And kind of this is a very confusing thing from a asset owner perspective. When you start to look at who do they notify and when do they notify them and who's their sector specific agency, and specifically kind of if there's confusion around should a particular company notify DOE, FBI, TSA, CISA, DOT, FERC, kind of all of these acronyms and names of organizations sort of circle around Colonial Pipeline for different reasons and different authorities. And some of those authorities have been discussed, kind of who should be responsible for product and pipe, who should be responsible for the pipe itself, and should there be differences? Who should be responsible for markets, and a number of different questions. From an entity perspective, usually the guidance that is provided is pick one. Pick one that you work with routinely. So in this case, most likely routinely doing work with state FBI points of contact. Put that notification requirement in an IR plan, practice it through exercises, test it, make sure it works. During an event, actually leverage it, provide that information sharing, and make adjustments if you determine that you could have gotten to other resources faster and possibly gained some additional help quicker had you changed your notification and reporting. In this case, the reach out to FBI and then FBI bringing in a number of different interagencies, that worked from the perspective of FBI has posted kind of an FBI flash very early in regards to what they've been tracking with this, with the notification that this was ransomware related, and then specifically dark side. So any of the indicators that they had and kind of being able to start moving and providing information and information sharing through a TLP green report out to other critical infrastructure. The development of a joint CISA and FBI kind of advisory on this matter. And with that information, that allowed kind of other organizations that have been tracking dark side and have been doing work in the space, being able to also provide additional information to kind of the community so that we could have a well-informed response. And again, kind of understanding that we're talking about this here today because Colonial talked about it to who they reported to. There's a number of ransomware cases that occur at organizations that don't hit media. There's a number that occur that could have operational impacts at organizations that we don't get the opportunity to look at, talk about, see the impact, try to understand it and learn from it. So really, really happy that Colonial Pipeline kind of had the approach where they shared information and they provided details to organizations so that we could all learn from this. Looking down, kind of once we became aware it was ransomware, once we became aware it was dark side, some information started coming out where a number of people started hearing about dark side for the first time. So first time you've learned of Colonial Pipeline and what they do and their role in critical infrastructure. And for a number of other people that might be in ICS or OT environments, learning about ransomware and these various organizations and group and tool sets, and kind of learning about this dark side ransomware as a service. The approach unique here, kind of the double extortion. You're going to pay to unencrypt your data sets, and you're going to pay to ensure that your data isn't released. Operation through a number of affiliates. So kind of people coming in and having various work for hire almost programs. Since this event happened, there's been a number of other information posts in relation to dark side that they claim no geopolitical affiliation and that finance and cash is their only driver. So you could imagine as they were performing these actions and looking for kind of the ransomware payout and the cash and seeing what this turned into by this target taking proactive steps to ensure safe operations and taking down facilities, it is probably fairly high levels of confidence to assume this wasn't what this adversary group anticipated happening. Some additional comments from adversary group or from dark side kind of providers along the lines of, in the future, they intend to provide more moderation and review of future targets to ensure a reduction in kind of this social impact. Definitely, this is a sign of ongoing progression kind of into full business models of organizations. This is going to continue to blend kind of the criminal and state-sponsored actors, and it's going to just continue to create this ever increasing challenge for defenders to kind of distinguish through the fog of war, criminal actions, state-sponsored actions, actions that are intended for IT, actions that are intended for OT. It's going to be this fog of war moving forward. Also, I just want to highlight kind of a recent blog post from FireEye on DarkSide that is absolutely a must read for everybody. This is highlighting the common utilized commercial available and legitimate tools, vulnerabilities that they're using for kind of initial compromise or for privilege escalation. A number of those vulnerabilities being exploited depending on the actor here in DarkSide, and a variety of different approaches observed across kind of this attack lifecycle. For anybody listening that is on the defender side or kind of consuming data sets, the indicators of compromise provided here should definitely be looked at and leveraged to inform kind of your action and your detection activities. All right, so that was the lightning round cover of the basics. With the basics covered and kind of a general understanding of the initial compromise, the adversary, kind of the tie to ransomware, the foothold establishment, and some of the attack approaches that has been seen kind of across organizational IT environments, we really want to kind of move and focus the majority of our time on discussing the operations impacts of this case study. I will call this kind of the elephant in the room question, and many conversations I've had with Jeff over the last few days and people in different industries and sectors, kind of along the lines of OT and ICS practitioners, sort of centering around this discussion of, hey, so everybody's saying it's ransomware. Everybody's saying it's impacting IT only. So why is there no product flowing? And kind of this discussion of what are we actually talking about? And is this an issue of, you know, a nuance between how somebody's defining kind of these strict differences between IT and OT and how those things in reality blend? Or is this, you know, a bit of a misunderstanding of kind of what was stated? So two things that I'll say here. One, I can't really comment on because I'm not inside of the organization, but I can say that, you know, when a company during an event like this, whether it's storm-related outage or a physical impact or some type of a targeted attack, when they're making a public statement on their site for everybody to read, that probably goes through many, many layers of organizational review to ensure accuracy of the statement, that the company was providing the best information available to all of its stakeholders in the communities they service. So words really, really matter. And kind of the first couple of sentences here in this statement, I'll paraphrase. Basically, Colonial became aware of a cybersecurity attack that involved ransomware. So that's kind of paraphrasing the first part. The second part is the important. After the discovery of ransomware, in response, we proactively took certain systems offline to contain the threat. That has temporarily halted all pipeline operations and affected some of our IT systems. So that's saying the actions to contain the threat temporarily halted operations and affected some IT systems. It didn't say ransomware only impacted IT. So the next piece is really where we get into the what is IT and what is OT, and kind of where these things blend and overlap and where one starts and where one stops. If you kind of very simplistically consider a bookend, you know, a bookshelf with IT on one far end of it and OT on the other end, there's a whole bunch of stuff that lives in that in between. And that's really where we want to sort of cover these topics of traditional ransomware attacks in corporate business enterprise environments, and then kind of this pivoting into industrial DMZs and these in-between zones where you have business operational technology assets and business intelligence and how they operate their actual facilities. All the way at the bottom of the stack, you have kind of the in the field, what they're doing kind of at their pumping stations and at their valve control and at the refinery storage pull and at their kind of delivery, as well as their terminal stations. That's clearly the OT side, and nobody is saying that this ransomware had some intelligence infected that or impacted it in any way. But there's a lot of stuff in between that in order to safely and reliably run your system, you sort of need. There's also some additional discussion around kind of in this in-between zone where you have between IT and between OT, you may have connections into other third-party environments, and that you want to ensure you're taking actions to prevent your attack from becoming somebody else's attack where you may have liabilities. So if you consider kind of their operations, very simple to sort of draw a box around, hey, they've got pipeline storage facilities, they've got refined products that are moving down a pipeline, they own and operate those pipelines. They have tons of digital communications infrastructure and control systems in place. And they operate multiple different products down that delivery system, kind of product sequencing those in, loading them in as batches. So they're pulling from these refinery storage product delivery sites and they're delivering into local terminals. And those two things are outside their box of assets that they own and operate, but certainly they have technology reaching into those environments to do that portion of their operation. Loading these things in as batches, kind of blending them and separating at the interface points when they're delivered, kind of using large area control center SCADA systems to monitor flow, pressure, quality, leak detection, just beyond the facilities that they own, consider the connections into edge environments and consider kind of the overall communications and control systems that are in play here. As we sort of move into what are all the other systems that they're using from a business perspective, I'm going to ask Jeff to jump in here and cover some of those additional thoughts on what we'll call, for the purpose of this discussion, trying to get away from the stuff in between IT and OT and maybe business operational technologies. Jeff, if you can see the slide, just let me know when you'd like to advance, and you're muted. Somebody needs to unmute Jeff. Whoever our moderator is, I can ask to unmute, but I can't unmute.
Okay, I think I'm there. I think they got me squared away. So as Tim's elephant in the room slide kind of talked about, as people were Googling and looking around, one of the biggest questions that we found was, how does an IT system actually interact with an OT system? So I wanted to kind of take a moment and explain that most large companies have different systems that take everything from customer orders and supply chain management systems and actually bring that down into the OT environment in order to be able to make a product. So if we look over at the right-hand side at the top part of the slide, there's a system that's called Enterprise Resource Planning, or ERP. And that system is used to take an order, to understand what raw materials, what things do I need to make my product, and also to communicate back out, hey, I've made a product. And eventually that ERP system will talk to a manufacturing execution system. And 99% of the time with large companies, whether you're making, bread or you're pushing pipeline products, there is a point in time when I say it's time to make an order, and that MES is kind of the bridge between a true IT system, and then it communicates down into the OT, or operational technologies systems, and tells it, like, here's your recipe, or I'm bringing back quality assurance information, or it helps me track work in progress, or WIP. It also does things like performance management. It tells managers and stakeholders, here's how fast I'm running. Do I expect to have my run done at the end of the day? It also does material tracking, everything from raw material to work that you've done. And those MES systems then affect the capacity of the plant. So for instance, it could say, hey, I know that this machine is idle. Let's go actually make some product because we have it in our bins, or we have physical screws, nuts, raw material. It affects the quality. It affects visibility. Where are these pieces? Where's the fuel in the pipe? And then eventually it helps us ship that product. So it does everything from, here's the labels that are on the side of it, and here's where it's supposed to go. And then it can communicate back up to the ERP system and says, hey, my product is actually shipped. So next slide.
A real quick 30-second example here, kind of, if you look to a different case study of NotPetya, and you think about some of the entities that were impacted there, kind of these systems in between and the importance of those systems in between, where a particular company like Maersk may very well have had zero problems on the far end OT side with port operations and crane or ship to shore crane control, They may have had zero problems with maritime and shipping and delivery on all those different OT systems in use and tracking. But if the issue is they didn't know what was inside the containers, that impacts all of operations. And kind of how you would delineate, was that an IT attack, was it an OT attack, and really kind of focusing on these systems in between, similar to what we're talking about here with Colonial.
Yep. One more comment is that MES system back up to the top is normally made up of like a database. It's made up of some kind of business rules that we're going to talk about, and then some kind of way to read how we're doing on our product. So I thought I would start talking a little deeper dive about autonomous control, or controllers or automation systems that are making a product and then reporting back when they're completed. So it's kind of like a band and a director. So the band, each member can play their own instrument. They can play their own music, but it's the director of the orchestra that says, here's the music that we're going to play. I'm going to hand you all of your sheet music, and then we're going to actually start. So for instance, if we go over to the left-hand side, the MES system on bubble 1 is going to determine what products do we even have. So in this particular example, I drew up that there's 3 tanks. Tank A has 5,000 pounds of product, and tank C has 1,000, with B being empty. So it would move to its business rules, and it would say, well, I can't make product 1 and I can't make product 2 because B is involved in both of those, but I could make product C because I could do A and C. So it's going to do something like then move over to step 3, create a production order. And that production order could be build this product using these particular weights, using a temperature, and I need a mixer, and I need to mix this product for 30 minutes. And that could be something simple like it creates that production order, and it gets entered into a separate terminal where production makes a schedule, and it says, okay, I have a customer that wants this, so I'm going to make product 3. Or it could be like what we're doing with digital transformation, where it's sending a product request in bubble 4, and bubble 5 is saying, hey, I understand that I'm supposed to make this product. And then the automation takes over, and this is where the autonomous control happens. So I know the music I'm supposed to play. I know that I'm supposed to work on this product and make it. So I don't need you to tell me what to do anymore. I'm just going to go make that product. So in bubble C, it starts to arbitrate for resources like a tank. So it says, okay, I've got 1,500 pounds of product. So I go over and I look at tank number 2 is capable of that. Tank 3 is not. So I arbitrate for it. I make the magic happen. I make the product. And then bubble 8, I'm sitting there waiting to tell you how I did during that production run. And in bubble 9, I'm sitting there holding the product, waiting for you to tell me, what do you want me to do with it? So this is at a high level, the orchestration that happens from very high level systems to autonomous control, making the product and reporting back what happened. Next slide. So what can happen in this scenario is if the MES system at the highest level gets ransomware or goes offline, then no longer can we send a product request or say that we've actually built it. So we have to sit there and we have to hold that data and hold that product until we can offload that information. And so it's not uncommon that we kind of do the store and forward methodology where I'm just going to wait for you to tell me what to do, or I have some manual method to actually purge the product, move it somewhere, and call that work in progress. Next slide. So in most cases, autonomous control will finish the last task and hold until further notice. It doesn't need that higher level system to actually do its nice closed loop job. And then depending on the work in progress, it can unload it. Or if the work in process is going to be finished later, it'll hold that genealogy and wait to be offloaded. Or sometimes it can hold enough and say, hey, I'll arbitrate for my neighbor and I'll ship it to them and I'll let you know about it. And then there's some sectors that might be handling live product or time sensitive product where they'll have manual control and they'll move that product somewhere else and they'll hold it or continue to finish it. Next slide. So winding that back to Tim's example is in the pipeline, there's going to be different customers' products. So that 5,000 miles of pipeline will not be filled with one customer's product. So inside of that pipeline, there will be probably a SCADA system that is remote, and it'll have some of the pieces of the puzzle to say, I know where customer's 1 product is, I know where customer 2's product is, I know where customer 3 product is. I might also have another SCADA system that's out on the tank farm that says, I know that I'm full and I know what product I'm holding. So I have some of the puzzle pieces, but yet I can't ship that up to critical systems in the middle, like doing some product tracking, or as one of the news outlets said, it might be a financial system that can't put all those puzzle pieces together. And technically right now, what a news outlet is saying is that those ransom puzzle pieces were able to be reconstituted so that they could pull all these things together and continue to move product. And as Tim showed on the map, make product flow again and resume their business operations. But that's kind of how IT can and OT can be heavily interdependent on this whole entire process. Next slide.
All right. So as we look at kind of the very beginning, IT, ransomware, kind of the great information that's been pushed out from Krebs and from Wired and from FireEye and others, and how that impacts IT environments. And that's on your one end of your bookend. And we've just sort of talked about the stuff that's in the middle. So these systems that some may classify as IT, some may classify as OT, and kind of they're really kind of the in-between space with architectures and segmentation kind of supporting it. But once you build those architectures and build those segmentations, you're still going to have to allow trusted communication flow from system to system, from interactive users, a variety of different needs, communication paths for not only the systems that Jeff sort of talked about with the ERP and manufacturing execution systems, but also there's some devices and some application sets and solutions that are being put in that are for cybersecurity purposes. So collecting data from the OT environment out and kind of aggregating it in this in-between zone, or patch repository, or AV updates or signature update repositories, and kind of being able to go pull from there from an OT environment. So not just the financial or the billing systems that are in between, but think of all the stuff that as a cybersecurity community, we often talk about, well, OT environments aren't doing appropriate patching, or they're not doing kind of monitoring and alerting and log collection or sound security practices. But as you begin to start to do those things and you have appropriate architectures of where those types of solutions are being placed, those types of solutions are also providing that in-between zone. So from ransomware, as it escalates beyond just IT and it moves into these in-between spaces, the next discussion that we need to have as an industrial control system community and critical infrastructure is what happens when it moves to the next pivot from that in-between zone down into the operational environments. So we're no longer talking about, well, was it an OT attack or was it not? Did it impact, how do you define IT and how do you define OT? But we need to start talking about the cases that clearly move into OT and begin to impact those types of assets. The number one thing to kind of think of is just ensuring resilient operations. And this is an area where kind of the different types of OT attacks that could occur, the different types of impacts on system operations, this is where the operators and kind of the resilience of the organization can kind of look towards things that they have done through normal events. So while this was cyber related, and there's some uniqueness there, had this been a physical event or storm related, if you look kind of specific just to Colonial and the operation across this pipeline over the last 20 years, they've had more than 30 events that have impacted pipeline operations, either in full or in partial. And most of us have never heard of Colonial Pipeline. So a number of people that are on this call, this is a company that is unknown to you, especially if you're not in the US. Depending on where you are in the US, you may have familiarity, but in regards to what they're doing or what products they're pushing or what would be the impact if it wasn't occurring, that's, depending on where you've worked, this may be unknown. And they've had more than 30 different events that were either rupture or physical impact, or Hurricane Harvey, Hurricane Katrina. The Harvey outages were probably double in length in regards to how long this cyber related outage is. The difference here, and kind of as those past events have happened, and you kind of look at those kind of 30 different events, none of them really bubbled up to, hey, we've got a whole of government response. We've got executive orders, we've got, kind of fact sheets and declarations of emergencies, and states and federal agencies declaring different waivers for EPA or DOT. The other kinds of events that have happened didn't sort of reach that. And I think it's just from the perspective of when there's a physical impact. So from a sector, electric sector, natural gas, or pipeline operation, when there's a storm, you know where it was, when it was, what the impact was, and you have a general idea from routine operations of decades of what that restoration and repair is going to look like, time-wise, and when you can anticipate full operations to restore. When you move into the cyber area and you're starting to now focus on how do we ensure we have integrity of our system before we begin operations? How do we ensure safety for our employees, for our customers, for the communities that we service? And now you're talking about integrity of a system that if you were buying that system brand new, you would have had system specification, factory acceptance tests, site acceptance tests, 1,000-hour performance tests. You would have walked through kind of full field point verification. May have been a multi-year project to bring it online. And now some adversary was in, and you can sort of see through forensics where they've gotten to and what they may have impacted, but are you certain? And at what level are you positive that you have a system with full integrity that you've restored from, recovered from, and now you can begin to operate? That becomes a less clear path, and really will only become clear with more and more exercises and activity, kind of practice the way you play approaches. Jeff's going to walk through a couple of other additional considerations kind of for OT environments as we start to dive deeper into where ransomware attacks may go in the future.
Thank you, Tim. Right now, ransomware attacks are kind of limited to computer systems and not embedded systems like PLCs. And I want to special note here is there have been embedded system malware. Right now, ransomware is just getting its day in the sun, kind of, so to speak. If you look across the fruited plain of industrial control systems and the computer systems that are in there, you would lose and have effects of not being able to get to your engineering workstation, which means no design tool. You'd lose visibility to HMI, to alarm servers, to historians, possibly analytics. Everybody's putting analytics on the edge or in the cloud, so it brings another vector in. You may lose SCADA function if you've had ransomware on a SCADA server, and inability to authenticate users. So the big news here is right now we're talking ransomware on computers. Eventually there will be ransomware on embedded system devices. Next. So I want to walk through an architecture. When I worked for Rockwell, we kind of made this kind of famous architecture model. It's based off the Purdue model. It's just our own little colors here. But at the top is the enterprise, and that is the internet-facing carpeted space, traditional IT. And what we found, or what I've found in a lot of assessments, is they aim the guns, or they aim and they look for the intrusion to happen in through the enterprise facing outwards. And they spend a lot of money and effort. And as we can tell, or as we think, a lot of companies, or companies that are getting hit with ransomware, this isn't really effective. But we also need to think about this in a different way as well. Next slide. In many cases, there are trust rules that allow the industrial zone to communicate freely to the industrial demilitarized zone, or the buffered zone between the carpeted space enterprise or the concrete space where we're making products down in the industrial zone. So a lot of times we just see trusted communications from plant level on up. They just say, you know, allow it from security levels. We trust the industrial zone. Well, this brings certain interesting side effects. Next slide. Many times remote sites are nothing more than an extension of the industrial zone. And so I find customers a lot of times will have secured communication through VPN or whatever, and they'll allow that trusted communication, or allow it in as trusted communication, And they'll tell me, they'll say, well, I'm fine because I have encrypted communication or VPN technology. But I'm like, well, it depends on what information you're sticking through the tunnel. You're just allowing it to be trusted. And so this is one of the warning signs, is that from remote site communications, we need to be aware that this could be a trusted entry into many places. And then one more hit on the slide is that the industrial zone is often very wide. So we don't do very good in OT as segmenting. And because we have things like, we don't know how many users want to consume our data in that top bubble, I'm trying to say, in many cases, we'll not only say, allow this particular asset to talk to the enterprise, but we'll allow entire networks to talk. So that can be a compact in. And then last but not least is these MES systems. In many cases, the vendors don't know how to work through a demilitarized zone. So we'll pop the ports directly from the enterprise zone down into the industrial zone because there is no proxy, there's no way to do it. And I've worked with customers where we've actually done peer-to-peer mapping of MES and saying how many things actually need to talk to MES. And we find that the MES system really should be located down in the industrial zone with very few connections to the enterprise that can be more secured. So again, technology is fine, but architectures are really important how you do this. Next slide.
Sorry, that was muted.
That's you're fine.
So we've sort of walked through kind of the areas of traditional IT ransomware, where that bleeds into these in-between systems, and kind of some considerations of targeting and access either direct at an organization or indirect through peer communications to other facilities and possibly even other third parties. That could slowly start to see ransomware moving into OT in these areas. Definitely kind of at that layer that Jeff talked about, from the engineering workstations, the operator HMIs, but also the information that those systems rely on, and kind of how you would restore and recover a particular operation, from project files to different HMI screens and tag lists, kind of the data sets and the systems in play. But Jeff also alluded to getting further in and kind of ransomware cases on endpoints, on industrial control system devices. And that's an area where Jeff and I will likely be doing some work in the future to sort of talk about how to think about those kinds of things, and maybe even some proof of concept areas that people should have in their minds as they're considering architectures and monitoring solutions. As we look towards kind of ransomware in those different spaces, and we look down into kind of incident response planning, in this last part of what we're going to cover here, really intended to just highlight a couple of key components across an operation-specific IR plan, and really kind of specifically highlighting, if you are an organization, don't point to your IT incident response plan and assume that it's good in coverage of your operation-specific environments. Really look towards OT-specific IR plans, and maybe even site-specific, because one facility to the next may be doing things completely differently. And you may have different operational avenues of continuing to provide safe, reliable operations through a breach or through a contested attack at one facility, where at another facility you may not. At another facility, if access is gained, there may not be a way of continuing operations safely. So definitely an OT-specific IR plan, possibly site-specific OT IR plans, depending on what that operation entails. As we sort of look at this across different time horizons, and we say, what should you be doing before your attack? What should you be thinking about during? And what should you be thinking about after? And kind of really focusing on this, this approach of OT-specific actions. I can't say enough, kind of the training of workforce so that they are aware of the environment and the kind of operation that they are supporting. So this is where kind of a hybrid individual comes into play, with kind of IT specific knowledge, as a lot of kind of these operational environments have traditional IT assets. OT specific knowledge, as you get down into the specific controllers and the specific industrial switches and protocols. Operations knowledge in regards to understanding how those things are used and how they're implemented and how they fail and what emergency operations may need to rely on different than normal operations. And then adding kind of this overall cybersecurity across knowledge across all of those different domains, you're really looking for very unique individuals and kind of this hybrid skill set or joint teams. If you have multiple team members with people with different roles and responsibilities that all share and respond together, and taking those joint teams and running them through exercises and ranges and talking about how you would respond to different events. Taking this webcast, taking this case study and replaying it for your organization, talking about those systems in between and talking about looking at firewall rule sets and firewall rule audits and saying, what are we allowing in and what are we allowing up from the different OT environments? What specifically could somebody kind of pivot from a impacted IT zone into this industrial DMZ and then down into the OT space? Or what if the OT space gets infected from a third-party connection? Do we have the rule sets to stop it from infecting up as we're looking to try to restore that environment and ensure that it doesn't impact our backups and other devices? Look at those architectures, look at kind of that information sharing and really focus on this operations sustainability and operations resilient architectures and segmentation. OT specific detection, we're going to talk about that a little bit on the next slide, but for a long time, we didn't have visibility into these types of environments. We didn't have the capability to kind of switch port span, work with industrial switches in ways where we could acquire data sets. We had to go with breakouts or tap points or individual hubs to even sort of see communications. Now, in most environments, we have the ability to acquire that data and gain visibility. So moving towards tools that actually understand those industrial protocols and can help you identify abnormal. A variety of different kind of procedural reviews to ensure that your OT IR plan is adequate. During, to the degree that you can move to manual controls or control inhibit or some type of operation to sustain operations and continue to produce kind of your product, absolutely that should be considered in your incident response plan. And we've seen in a number of cases kind of the ability for organizations to do that is well understood by operations, but the people who are aware of the cyber event are focusing on kind of tracking and identifying and containing the adversary action from a cyber perspective, and no one is doing the operational containment to ensure that the operation isn't impacted. So again, not only making sure your joint teams of cybersecurity practitioners are working together, but that joint team includes operations. Because in many cases, operators during emergency operations can move to manual or control inhibit. An assessment approach of evaluating the integrity of the system, an ability to operate through, or a decision to move to a scheduled outage, and kind of overall information sharing. After kind of this restoration and validation step, that could be a very, very long process, including safety walkdowns, analysis, a whole series of after action actions. Kind of if you look at this from the perspective of Colonial Pipeline, starting this planned startup and restoring operations, that they have a long tail to this event that's going to go on for a number of years in regards to information requests, data requests, upgrades or changes to their environment, looking at how they can operate differently, tremendous amount of lessons learned. And we can only hope that there's still continued information sharing so that others can learn from this as well. The one piece that I've sort of heard is kind of the clearly this has impacted an IT side of their organization. And again, we can talk about the stuff in between, but having this resulting outage, that would indicate to most people that they weren't prepared. And kind of to this point here, I would counter that and say, the fact that they detected it, the fact that they were aware, the fact that they moved down to the next step of seeing where it had gotten to, and they had likely run through exercises to develop a procedure to say, if this condition exists, it presents this risk to us, and we need to start contemplating how to contain and how to potentially impact or perform a scheduled outage. That they had walked through all of that thinking prior to this event, and they moved to proactively taking down an operational asset out of an abundance of caution. I think that is indicative that a number of these other things had to have occurred prior to this event, from a training, from an exercise, from discussions of when to disconnect or how to disconnect, and then actually executing on that with approval from leadership, understanding what the financial impacts and risks are. That's a lot of conversations and a lot of activity that had to occur in order for this system to be determined to be taken down on Friday, based on what they knew. If none of that had occurred, likely it would have been up and operating and available for an adversary to continue on to the next step and further impact assets and have a longer extended outage under the control and authority of an adversary group instead of the asset owner and operator. As we talk about kind of these detection times and the need for OT specific detection capabilities, kind of at this point when things move from the traditional IT into the in-between space and then down into the OT segments, you're really looking to where can you place sensors? Where can you place detection capability that you can start to reduce this ICS compromise to detection gap? And you can start to then further inform response teams to further reduce this detection to containment gap. And then ultimately, if there is an effect on your system, because of all the actions and how you've positioned this and what you've detected, you've taken a series of steps that even if there is some effect, you've reduced the overall impact of that effect, and now you're reducing the containment to remediation gap as well. Jeff, we are going to have you walk through a couple of these different types of assets and kind of thinking about specifically from a ransomware perspective, you know, how these assets could be impacted and how you could better prepare yourselves from an IR perspective prior to the event and during and after.
Sure. Yeah, absolutely. So within industrial control systems, some of those things are foreign to our IT brethren and very comfortable to the OT engineering group or maintenance group. And so what needs to happen is this is my method, is I take all the ICS assets, the types, and I break them down into kind of their indivisible parts or their atomic elements or whatever fancy words you want to use. But for instance, on the PLC side, I've got, you know, firmware, I've got a program, I've got data, I've got configuration, I've got design software. And so I take those elements and I say, okay, during a complete outage, I need to have available to me for restoration purposes, the firmware, the program, very specific kind of data, which we'll talk about, any specific configuration and the design software to be able to load it. And I kind of walk through an entire environment and determine what those things might be. As we move to the HMI, same thing, smart valves, switches, routers, and firewalls. So we would call that infrastructure. So I divide that off into a separate category and I go get switch, router, and firewall experts. So not every OT person is familiar with that. So we might lean on the IT side to say, hey, can you help us restore this or configure this? Help us get visibility back. And then last but not least, from the server and application side, what was I running from an operating system? Can I even put it back? You know, it's surprising some of the old operating systems that are running current ICS systems, and we need to be able to put it back because that was what was validated. We need to have access to the patches, the applications, and the application patches. And so what tweaks? So Jason Deely kindly remind me, hey, remember when we tweaked the operating system for this or that to get this run? It's like, oh yeah, so somewhere we need to have this kind of design methodology when we back things up and we have to go back into a restore. Next slide. So truths about ICS, some axioms for us. A lot of times backups in the ICS absolutely exist, but they're hardly ever current. So we can do things like get in there and we can force IO subsystems to be in a certain state and we never back it up. So you can plan for number 2, which is plan for your worst day scenario where you're going to rebuild from scratch, where scratch means you can get current day operating systems and you'll have some out-of-date artifact and you're going to put it back together and then you're going to start working through the problems. That will take you a long time. I've seen it happen. I've been part of that scenario. It's not comfortable. Last but not least, don't expect that your OEM, the people who provide that equipment to you, or your system integrator will save you, because they will not. They will not have backups that are equivalent to what you're running. So don't, these are kind of the things that I've learned the hard way. Next slide. I wanted to specifically talk about code. People will run around saying, hey, we need to back the code up. Hey, we need to back the code up. And that is true. However, the code needs to be protected as well, not just from a restoration standpoint, but also from, if I get my hands on code, I can understand the operational importance of the machinery and things that I can do inside the code, either to the data or to the code itself, in order to make the machine behave not as intended. So the code, yes, we need to back it up, and yes, we need to understand that it is current, but we also need to know that it tells an adversary how things are running. Next slide. As part of the recovery plan, data types will tell us what kind of recovery plan we need. So generally speaking, I've broken it down into 4 categories. There's dynamic data, which we don't have to really, in quotes, back up, because it's computational data. It's something that is constantly changing. As soon as we turn the system on, is going to be computed. There's recipe data, which we can restore, and we can say, hey, put the valve settings to this, put the temperatures to that. We're going to run this product. It is not real sugar, it's brown sugar. So let's do these batch kind of things. So we can put them back, but that can be held for ransomware. So we need a recovery plan for that kind of data. Current batch or product data. So we saw in the Colonial Pipeline, I'm sure they had current data about what was in the pipeline, about what was in the tanks. And so we needed to understand that if we hit the go button, what's the real current batch data that we need to make sure that we do. Sometimes we can get a good snapshot of that before an event occurs. Not all the time. We may have to reconstruct that. And then last but not least, I call it conditional. So there are some machines where you actually have to zero machinery, and you have to build pressure, and you say this is 0. Linearly it's 0, or pressure-wise it's 0, or I turn on a pump and I say this is the new idle pressure, or a robot, I got to home it. So these are the kind of data, types of data that will actually drive a recovery plan. Next slide.
Thinking about kind of that recovery plan, as Jeff just walked through kind of the different pieces of data that you would need from the various devices and systems, that if that is impacted or kind of made unavailable, and you're looking towards kind of how do we restore, how do we recover. And that's really where kind of this discussion that should be familiar to many from an industrial control system perspective. If you're needing to go back to an as designed or an as built kind of recovery, because that's all that's left after a ransomware attack, you likely have a lot of things to do to move it back to an as operating condition. So kind of that difference between as built, as designed versus many, many years into the future, the as operating, and all of the changes and modifications that have happened across operator displays, across kind of device configurations, and ensuring that you have kind of those absolute current capabilities to restore from, and not just sitting on an engineering workstation, but also elsewhere. Kind of considering some of these things that would squarely fall into the preparation side of where do those recovery capabilities exist. And then if you move down this operational IR plan, being able to access those and use them, and then validate when you're in a recovery phase. Kind of 2 areas to highlight here. This containment piece is looking towards an effect that's achieved in an environment, and then being able to sort of walk back up to say, based on what was demonstrated, based on what was observed, or based on what was discovered with our OT detection, here's where adversary must be, or this is how they likely gained access through based on trust relationships. In order to do that, you absolutely need to understand all your data flows, all the communication components that are coming in through industrial DMZs, through third-party vendors, and even getting that documentation and getting it all put in place as part of the preparation side to know what you know, kind of the inventory of hardware, the inventory of software, the configurations of various devices, the data flows that exist in your environment, That is a large effort that needs to be done kind of before the incident in the preparation phase so that you can understand it. On the operations side, the point Jeff just made in regards to what was the state of the system in before the event happened. So what were the current products in pipe, customers, delivery points? What was our current state of operations before it happened? So using things like historians and trend lines and other stuff that you could go look at to sort of reconstitute the state of the system. Also the ability to have some isolation and manual control so that you can operate through an event, or the decision-making in place to say when you can't. That based on what we're seeing, based on adversary position, based on demonstrated capabilities, and the ultimate risk to safety of personnel, of equipment, of kind of the communities that you serve or customers, and the decision-making clearly in place on when to kind of move towards these scheduled outages. Absolutely kind of looking through this from the perspective of an OT lens, consider kind of your OT specific response plans. We only have kind of one slide left, and we'll be seeing Rob T. Lee emerge soon with the hook to take us off the stage. But one thing that we sort of would talk about here is kind of this response, kind of this all of government response that has come. And this is generally not what you would want to see if you were in a ransomware team impacting a company. Kind of an all of government response with kind of 9 different agencies all operating, waivers for EPA for non-compliant fuel delivery, DOT extensions and waivers for tanker trucks to have alternate means of delivery, individual state actions that went down, kind of expanding weight limits to exceed for tanker trucks and operations, considerations of alternate transportation on rail or maritime vessels. This has bubbled up very, very high in regards to how do we continue to operate through this attack, and what actions should we take, and how should we prepare as a nation, and how are we going to respond to this? Assume at that level of bubble up, this isn't going to go away now that everything's restored. There's going to be ongoing discussions of who should have what authorities. There's going to be ongoing discussions around what regulations or what requirements should be put in place. There's going to be just a tremendous amount of activity geopolitically about how do we start to respond to these types of ransomware cases differently, as we expect they're going to continue to rise as well and move more into critical infrastructure, more into OT kind of specific impacts, and really kind of become this fog of war in regards to, is it a criminal action or is it a state-sponsored action? And being able to understand that and differentiate, and then the need for defenders to have that training, have that visibility, have the skills and abilities so that they can respond to these kind of increasing levels of attacks and complexity. This slide, again, slides will be provided in PDF, so a number of the different resources that we use that fed into this. And I believe today we have a SANS ransomware page that has been put up with a number of different resources available. There's a lot of different areas of SANS as kind of you look at training or an educational institute that may have a college of business, college of law, college of education. In our curriculums where we have forensics and blue team operations and pen testing and offensive ops, ransomware is kind of sprinkled throughout, and something that we're all facing and all dealing with, not just kind of in the ICS space, but in a lot of different areas. So kind of from a user perspective on security awareness and resources there, to a forensics perspective, just a tremendous amount of resources and activity occurring in the space. Would highly recommend kind of going to check out some of those resources on this page and plugging into some of these talks that are scheduled for the future. With that, we are 4 minutes over, which I'm actually impressed that Jeff and I landed 4 minutes late. But here's some additional resources. Jeff, thank you very much for joining me today. And Rob, I turn it over to you. I think you're muted, and you likely need to request an unmute. So whoever your operator is needs to unmute you. In the meantime, we could say whatever we want. Jeff, we can keep going.
2 computer strings walk into a bar.
Oh, Jeff's humor is something you really got to get used to.
Yeah, it takes a while.
Rob, I don't know if I cannot unmute there.
Nope.
And I do not
Now
know.
I'm unmuted. Yay. Okay.
Hey, there you go.
Thanks,
Thank
guys.
you, Rob.
Tim, one of the things that you said earlier about the number of events that happened on the Colonial Pipeline, no one even heard of it. You said there's 30 of similar shutdowns that have occurred over, what was the time frame again? I was trying to.
So over 20 years, CNBC has a good kind of timeline of this where they're walking through kind of, hey, when Hurricane Katrina hit, it impacted the refineries that were bringing product in. And so pipeline operations was not occurring. And that lasted for, kind of 8, 10, 12 days. And kind of the speed of this product moving across the pipe, I believe Jeff referenced kind of a 5-mile-an-hour delivery speed.
Right.
So even when it started to restore, the time it would take to make its way all the way up to different terminal stations, extended restoration. Hurricane Harvey actually impacted pipe from flooding conditions and other issues. So it also caused full disruption. Across those 30 events in 20 years, there was other smaller ruptures and pipe leaks and other things that were partial impacts. But this is like any other critical infrastructure where you're operating physical assets deployed throughout the field. There's outages and events that occur all the time, but the resilient operations make it so that there's all kinds of other emergency plans like tank storage and alternate delivery methods where kind of the customers and communities they serve are often not aware of the different failures that have happened throughout time. This one being unique as it's cyber and it's less planned, less predictable, and kind of an emerging issue.
In national news, yeah. I really thank you guys for putting this together. I mean, the amount of expertise and insight that you're able to bring to this, and just general knowledge of information just like that, really brings a steady hand to the current events that are going on. For everyone who's attending, these slides, the presentation, and additional resources that were linked in this presentation will be making its way onto a blog that we're going to be posting on both Twitter and LinkedIn and on the SANS website. But I really appreciate both of you for taking the time to put this together. This is no easy task. The amount of information in depth in here is flat out amazing. I really appreciate everything you guys do to continue to contribute to SANS and the overall information security as a whole. Without further ado, thank you all for attending the emergency webcast. Pay attention to social media at SANS Institute and on LinkedIn for the posting of the blog that will link to the slides in the webcast. Thanks, everyone.
Thank
Thank
you.
you.